Hey, what's up, all? Welcome to my stream. So I'm running a lot later than usual, so it's probably gonna be a shorter stream, but that should be all right. To be honest, I have no idea what I'm gonna work on tonight. I have all kinds of things I was thinking about. I know like a couple nights ago, I was looking at this list here and remarking that there's this unhandled operation, which is this interrupt, SWI. I also have other ones here like CWAI, but when I look at which ROMs they're for like, you know, alternate versions of the main commercial ROM. So, and I only have a few of these right now. I mean, these are the only ones. So I do need to get to them at some point, but I'm not sure I want to focus on those just yet. Hey Lisp Gamer, how's it going? I'm pretty good. To be honest, I'm a little bit under the weather. I'm going to be drinking a lot of liquid. I have a little bit of a cold coming on. You might hear it in my voice. But yeah, you know, it's par for course up here. So yeah. Yeah, 10 centimeters of snow. I know. That's another reason why I need to end the stream early. I'm going to have to go move my cars and remove the snow off the cars and stuff. So yeah. I'm not sure, like, I want to work on that. So one thing I had mentioned last stream was like maybe taking a look at trying to optimize the way I build my list of lines, and starting to focus a little bit on cleaning up the code on the VIA side here. Not that it's like super messy, but like I need to start refamiliarizing myself with this code. There's still a lot of stuff I need to do in here, and I'm pretty sure like most of the problems that I have right now are just related to that. I have a couple of these VIA not implemented, so those are those for sure, but others that are like, I think these invalid cartridge reads and stuff like that may be related to those. So yeah. In fact, another thing I was thinking is maybe doing some performance profiling, and just to kind of get a feel for where things are, where we're spending some time, at least on the CPU side. Like I could just use this one here. Is it this one? Yeah, like let's do the sampling one. So this one in Visual Studio is pretty good. Let's see what happens. Okay, we should have enough samples now. Maybe too many. So last time I looked at profiling, what I had noticed was that we spent a lot of time processing the lines vectors. So I just want to see if that's still the case. I don't see why it wouldn't be, but you know, best to optimize with some numbers and some actual profiles, right? So okay, so let's grab let's say a region like this, and I'll just say filter by section. just to kind of get rid of the startups and whatever. Okay. So it's saying that we're spending most of our time in, where is this? Debugger update. Specifically, okay, well, not surprisingly, executing instructions. So for sure, our executing instructions take some time. So let's see here. See, this is a pretty cool. It's a pretty cool analysis here. You get to see like the number of samples that it recorded on these lines. It's pretty nice. Okay, so this here, it's always a bit confusing when we have lambdas involved, but basically execute instruction is this lambda. Unfortunately, its name is, you know, this generated one here, but we can see that that's what it refers to when we click on it. So we have let me just go up a bit here. Okay, so yeah, so we start at the top here in STL main. So run obviously takes the majority of it. And then in run we have update and render scene. So just curious, if I look at render scene, this is the part where I knew that we were spending some time, which is the drawing. And here you can see we've got the vectors of vertex data. Draw vertices here. So definitely there's some time to be saved there. So debugger update. So an execute instruction. So yeah, actually the hash instruction trace info is taking quite a bit of time. This is actually something we could totally skip if we're not in the process of, you know, doing the desync detection. I left it in there because I don't actually communicate now anymore, I think, at this level. Or no, actually I do know at this level, so I could totally skip this if we don't need it. So yeah, that's gonna save us a little bit of time there. Actually, quite a lot of time. Yeah, I see it right here. Functions doing most individual work. CRC32 is right at the top. So yeah, that definitely is showing up. Yeah, so that's really right now where our biggest cost is for a function that we don't even need to call unless we're doing our desync detection. So let me let's get rid of that cost for when we run without the desync stuff. So I have this function sync instruction hash. Okay, so this is what we'll do. Oh, can't do this because this is anonymously defined. Alright, whatever. You thought of me yesterday? You were writing code to do type dispatch, implemented most of it using templates? Because you've been seeing all my templates in my code? Is that what you mean? So for not standalone, yes, I am big into using templates for sure. I mean, if it gets the job done, right? Right, okay, yeah. Well, now, you know, it's templates and or constexpr, if I can do it with using constexpr, because it's even easier to write than writing a bunch of template metaprogramming. But definitely, if I can get the compiler to do it and it's type safe, yeah, I prefer using templates. Okay, so now let's try. Do another profile with this. Yeah, I can't do macros unless it's like macros for me is a last resort. I do use macros, but when I don't have to, I do avoid them. Just literally because I find them really difficult to debug, you know. Single line macros, not the end of the world, you know. So it's not the end. I don't mind too much, but it's when it starts to become multi-line that I find it difficult. But like I have a few, you know, like stuff like these. These are all macros, right? Stuff that kind of has to be macros. You see, I have a few things here, like optimize off, optimize on, stuff like that. Here's a macro. Bits. Yes. So it's interesting that you you mentioned that, like having to implement all the operators, and you can like write all, you know, most of them in terms of one of them. You know, although the ones you mentioned probably not, but yeah. So I said it's interesting you mentioned that because there is some work that's being done by this, you know, Herb Sutter. If I can find it. So this guy Herb Sutter, he's the chair, I think, of the C++ standards committee. He works at Microsoft now. Well, has been for a little while, and he did an interesting talk at CPPCon 2017. On, yeah, that's it, on what he calls meta classes. So this one here, you should totally watch this. It's I mean, it's not something we'll see in C++ for a while, like definitely not for the next ones. It's not going to be in C++ 20, but maybe C++ 23 or something. But the idea is to solve that problem. It's being able to express what we cannot express right now using templates, but what we can with macros, but at the compiler level, and it's really interesting. It's see if I can find just like as an example. Yeah, so here you start to see like, he says the syntax is not the important part, but stuff like this, where here you have an enum class state with started equals 1, waiting, and stopped, and he wants to be able to write a function, print strings, right, that will print basically these names, started, waiting, and stopped, which are, you know, known to the compiler, but that we can't easily stringify. So this is like a typical thing that we want to do, right? Being able to take our enums and have the string version of those values. And then so here you know, this would be like one example of how it could work, where you'd be able to loop over, let's say, the whatever your type name here E is. In this case, it would be an enum. If you could access its variables and run over them, you could grab their name, for example. You know, so this is the kind of meta programming he's talking about. Anyways, you can definitely watch it. I'll paste it into here. So it's some interesting stuff. All right, so let's go look at our latest capture here. Yeah, so in this case, it's a form of reflection, but it's more than that. When you'll see when you read about it, it's also about generating code. You know, so this is an example of reflection, but there's also, like, for example, ways to define sort of like a template. You know, and that's the wrong word, but I want to say, like, here's a class that represents a value type that has, let's say, all those operators you showed. You know, and I want to be able to say I'm going to generate a class for vector, you know, or a math vector that implements those functions, and it'll just kind of generate the code for you. So basically what you're using macros for, but it's more powerful than that. I'm not really doing it I'm not explaining it properly, but definitely just take a look and you'll see what I mean. All right, so now that we got rid of that, did this even filter? Okay, so yeah, see, now we got rid of the CRC, and our cost actually is stl function name render scene. See, now it's going to be in the rendering code. Now we're spending most of our time doing the GL render scene. And so we're back to, this is what I was showing before, which was like the second hot pass. Now it's the main hot pass, and it's the part where we are spending our time doing draw calls. And I suspect that the main reason is because of how large our buffers of vertex data are. Kind of cool how it shows that we drop into the into my ATI OpenGL driver here. Apart from that, we spend time obviously executing instructions. But this is not much I can do about it. This is just a, you know, it makes sense that most of the emulator time is spent in here, especially in the part where we have to do reads and writes to memory. Right now, the highest cost thing on the CPU, like outside of rendering, is looking up, like accessing the memory address bus. So these read and write functions that call find device info here. So mostly we read, and when we do that, we call this find device info. And let's see here. whoops. Okay, read. Okay, because it's been optimized. In fact, yeah, so that's it. When we go into find device info here, what I do is I basically iterate through my devices, looking at their memory ranges and seeing if the address we're requesting is within the range of one of the devices attached to the memory bus. And then if it's there, I return that info, and then we use that to, where is it? Yeah, in the read here. But actually another part of the cost might be this. Hold on a second. No, that's it. It's the find device info. Yeah, so you're asking if I've thought about using mapped memory. So or read-write tokens. That I don't know what you mean by read-write tokens, but for mapped memory, definitely I could do that. That's definitely an optimization that I could make, where I could like separate my memory map into chunks, and then have like, let's say for whatever set of bytes, point to a function that it's already mapped to the right device. So not a linear mapping like this, where I do these these compares and all that, but just basically a O1 lookup. And I suppose that's what you mean when you say mapped memory. So yeah, I could absolutely do that. That would work as an optimization. I'm not too concerned right now because it's not actually showing up as a huge cost just yet. It really, like, to me, that's kind of like normal cost. And if I really had to make this run really fast on on a really low end machine, then yes, I would definitely look at that. Oh, okay. Okay, I see what you mean. Like, you mean using actual like virtual address pages or virtual pages. Read-write tokens, I mean you allocate another 64K page and put bytes to represent the memory op type. I'm trying to think about how that would work. Yeah, for sure using virtual alloc and virtual free and all that, it does require me to have that available on the operating system. So I'd rather not. But what I was thinking was something else. What I was thinking was more like, if I can make sense of it here. So let's say you have like a 64K address space, right, which I think is what I have. You kind of like divide it up into whatever kind of buckets you want, right? So like maybe we divide it into what would be a good, into, I don't know, 1024. So yeah, let's say we divide it up into 1024 buckets, So that gives us, what is it, 64 bytes basically, is that right? Yeah, so it makes sense, 1K, 64 bytes. And then basically what you do is you take your address, and so you think of this as, I have 1024 buckets, and then each one of those is mapped, like, so let's say the 0 with 1, which represents like bytes 0 to 63, is like, it's a table or whatever. It's this here has an entry which is like a function pointer or whatever, you know, like a pointer to the device that I need to read from, you know. So yeah, it could actually just be like a pointer to the device itself. And so we just keep doing that, you know, 64 to whatever, and we continue, and we have all this mapping. And so, you know, obviously there's going to be a whole bunch of redundancy in there. And then when I get any address, I just divide it by 1024, or actually modulo it by 1024, I suppose. No, I guess divide by 1024, get, and then just do a linear lookup and get the device and just call it. So I don't have to do this, because right now I'm actually literally going through an ordered list, like an ordered vector of these devices that have memory ranges, and I check, like, is it in the memory range of the first thing? Memory bus, is it? Yeah. So basically I have these bus devices on my memory bus. The 64K? Right, yeah, sorry. But yeah, so like, that's it. Right now you can see it's really not optimal. I assume I go here and I'm like checking, you know, is the address greater than for each device. I check if it's in the range of that device, and I do assume that there's no overlap and that they're ordered. That's true. So all of this could be replaced with a linear lookup, an O1. This is an ON lookup, and with a bunch of compares, and I could optimize this. Get rid of the compares, just do a divide and an O1 operation to get back the device. You're saying changing this to doing what I just said? Yeah, I mean, it would make a difference. So like, actually, when we look at the profile, you can see that at the very top, where most of my time is spent is in two functions, render scene and update here. Now, render scene, that's, it's practically the same amount of time, you see, in terms of samples here. So 3,600 versus 3,400. So about half the time is spent rendering and half the time is spent updating. Now for rendering, I'm pretty sure it's related to what I was saying. It's the fact that I just have too many lines in my buffer, and I can easily do an optimization there and coalesce whatever lines into less lines, because right now I have just many pieces of the same line. Otherwise, on the update side, yes, most of the time is going to be spent in the memory bus read, and so this could be optimized with the way we were saying. So I do not new the vector each frame. Yeah, you're talking about on my list. So it's this one here, this vector of lines here. I don't. Okay, so I place it here. This is a bit of a hack, but I do the clear over here. But this doesn't actually. You know, this keeps the buffer in memory as large as it is. So I don't actually reallocate. There's no, it's not a heap. I mean, it would show up in the trace, right? If that was actually the problem. But it's not that. We're not spending time reallocating memory here. So that's the lines vector. And then what we do with it is we call draw lines. So there is here a copy. So this copy here, like, it's just copying memory. Shouldn't be reallocating. It should just be reassigning and copying the memory. So there's a movement here. Yeah, and I even wrote here to do move. I could move this, but again, it's not really showing up. And then here, this here is definitely expensive. Here I am allocating. These here I could optimize. Like have just you know, globals and just resize, refill them up. I don't need to be reallocating them every frame, for sure. Yeah, no, I know. But again, like, we're just looking at the samples, we're not spending time at that point, you know? We're spending time basically in this GL buffer data here and GL draw arrays. And in both cases, we're dealing with the vector itself. And what I suspect is happening is that basically the driver is copying here. Like at the driver level, the GL buffer data and the GL draw arrays is making its copy. And these vectors are large, right? They're huge. I mean, actually, I could put a breakpoint and just show what it would look like typically. So let's say, go to that function, 288. Let's say I'll start the emulator just normally. Let's get into the game. Yeah, so for the flags, I do set them to be dynamic because I am constantly copying memory to the driver. So here, this buffer here is 7,372 little bits of lines in there. And that's just one of the calls because we actually draw, so we have one here and one here. So that's, I mean, it's not, I guess it's not immense, but let me see here. Yeah, so the number of lines here, now of course I'm getting larger delta times. But you see, like, we're at 13,000, and that's per frame, and I'm doing quite a bit with those lines. So I could definitely dramatically reduce the size of this. Do I set no overwrite? Do you set no overwrite? As a flag on the buffers, you mean? I'll take a look. I'm trying to remember where I set up my buffers. I don't think it's here. I think the flags is not here. It's where... Let me see here. So there's this one here, GL dynamic draw, but I'm guessing that's not what you mean, right? What's this no overwrite? I'm not sure I know which flag you're referring to. Anyway. Yeah, I'm not sure. Not sure which flag, but I mean, I really do think that probably if I just reduce the size of these vectors, we'll see a. I could like try a little hack, you know, where what if we did, I could say, a resize here. Let's say we were to reduce the size of the number of lines we have by like, I feel I could reduce them quite significantly. Like, let's say down to, let's say, 25%, you know? See, now we're getting less lines, obviously. So let me try and do a trace with that. It would be interesting to see if I had about 25% of the lines that I'm currently generating, would it make a difference? And I mean, I'm just guessing here, but it might even be better than that. Because like I said, most lines are straight. You know what I mean? So you think about it, it could be even much more dramatic than that. Well, I mean, looks like I'm still got the same hotspots, but this might not mean anything. I have to look more at the absolute values. Let me try something. See, I was getting 160 frames per second average, and now I'm getting. It does fluctuate quite a bit though, so it's hard to say. Oh, right at DirectX. Okay, so it's not OpenGL, but there may be something equivalent, right? But I think that's what the dynamic flag that I'm setting is for. this G dynamic draw. And there may be other things here too, like I am creating, there are some places where I'm creating buffers where I don't need to create them every frame. So yeah, there's maybe some optimizations to do there. Anyway, I'm kind of interested to see what I could do with these lines, just kind of for fun, you know? Yeah, I'm not quite understanding what you mean, Lisp Gamer, for the... Oh, okay, right. But why would I need to use 64K pages for that? I mean, what I was saying was pretty much that, right? Except it doesn't have to be every single byte. You know, it could just be some range of bytes. Just mask off some bits and, you know. Oh, okay, because you're saying there's actually 64K of memory. Right. Yeah, I mean, I suppose it's just 64K. Yeah, I could do byte for byte, that's true. That's totally valid. Yeah, that's true.
Now I've got your power.
So, alright, let's say we jump to that since we've been talking about it. CPUs are fast. Yeah, no, for sure.
Give me that. Give me that. It's a done deal. Oh, wicked one. Mega's too weak to beat Proto-Man. Mega's too weak to beat Proto-Man. Oh, wicked one. Proto-Man to the rescue. Proto-Man to the rescue. My Proto-Man. My
Yeah, sorry. I think you're losing me a little bit there. But let me just see if I can do something. Just let me think a little bit here. No, it's not 64K. That's what I'm saying. I basically have devices. I don't have like a big, 64K buffer. I have a bunch of devices. Each device covers, like I have a memory map. This is the memory map for the Vectrex. And so for example, cartridge ROM space makes up the first 32K. Right? And then there's some unmapped memory here. Then we have some memory here for the RAM. It's 1K. That's shadowed twice. I have here the VIA, which is 16 bytes, shadowed 128 times. And the VIA and the RAM selected here. This is like illegal. But if you access this, it actually selects, both VIA and RAM at the same time. And then finally, we have the BIOS, which is the last 8K in RAM. So that's how the memory map is laid out. And so what I have is, so this is the mapping. Then I have a bunch of devices. Each device implements this iMemory bus device. So for example, the cartridge, right, is an iMemory bus device. And the way it works is that it has a read and write. And so here it just basically uses that memory mapping just to this takes care of I have this map address. This is more of a little helper to make sure that if there is shadowing, it just takes care of wrapping the value back into the valid range. So it takes care of that using the memory shadowing, taking shadowing into account. So I have physical and logical size for that. So yeah, and then basically each device connects itself to the memory bus with this connect device, and I just push it back on this vector, and I keep it sorted by the memory range's first address. So I know there's no overlap, and so this is a sorted list of devices in terms of the memory map. And then when I do a lookup, I search through and find which device it belongs to. So that's what I was saying. So instead of having this like a vector of devices, I can just have I could have here the 64K of memory with the device pointers in there, and just have like redundant pointers to the devices. And that right there would just get rid of the lookup cost. This kind of looping that I do through my devices would be yeah, exactly. I don't really think I need to go to that level. The only problem is on x86, byte reads can be costly. So actually address is actually 2 bytes. But 2 bytes map to 1 byte, you know what I mean? It's 2 byte addresses for 1 byte values. So it's actually 16-bit addressable. Yes, exactly. It is reading bytes though. Yeah, I'm not going to worry too much about that. So it's just like, I'll just try something really dumb and just see how it works out. Yeah, I know. I don't remember if this was inclusive. It is inclusive. Yeah, I'm tired too, and I'm a little sick, so my brain's running at like sluggish speed mode right now. So I think all of it is mapped, so I'm just going to make sure of that here. Sorry, man. Alright, so let's see if this works. I basically made it a array of 64K entries of iMemory bus device pointers, and then when we connect devices, I just go and fill up for the entire address, for the entire range of addresses, the pointer to that device. And then when we do a read or write, I just look up the device immediately for that address, and I just call read and write directly. So we don't do any more linear lookup. So if I actually did this right, it should still work. Or do that. It looks like we're in an infinite loop. Oh, I might be hitting up against the fact that we wrap around for the last one because it includes the yeah. Let me just make this large enough. There is no overlap. Like, I already assume no overlap in this code. Like, the very fact that I'm sorting by the memory ranges first, and in my lookup here, I already said we assume at least one device connected. This one condition allows us to check the address against the n. I didn't write it here, but I'm assuming no overlap because as soon as the address is less than the second value in the range, I assume that's the device. So, and it is the case for the Vectrex. Didn't you describe it? No. So yeah, so that region is true, but I don't actually do it with an overlap. Because I'm just gonna, what I do for that is, so I call that the illegal range. See here, I call it illegal, and I actually have an illegal device. I just don't allow it. And I know that if a game did on real hardware, it would, quote unquote work, right? But I don't even know what it would really do in hardware when you try to access, a range that's mapped to two things. But in any case, I have yet to hit a game that does this on purpose. You know what I mean? What did I do? How did I... I don't even know if I did make a... I know I have an unmapped device, but I think for illegal, I just don't have anything. So I guess I would get... I would hit this assert unmapped address. That's what would happen. It doesn't look like it changed the performance, to be honest. So I'm just going to take a look at it. I want to see what shows up in the profile. It's not a 64-bit build. It's a 32-bit build. I've been wondering whether I should make it 64. Yeah, pointers are 32-bit. Because I mean, generally, right, like 64-bit builds they afford you a larger address space, but I don't think they necessarily give you better performance. In fact, I believe they give you worse performance, right? In general? Or is that like you know, old information. Maybe it's not true anymore. Yeah, it depends on a lot for sure. So actually, I think now looking at it here, I think we did reduce the cost of the read, which is good. And now we're getting the cost of this. This here, this on-read callback thing, this is only for my debugger, and it's for my breakpoints, being able to have watch points on reads and writes. So, you know, again, this is not like absolutely necessary for the final emulator. And when I don't have it yet, but when I make, let's say, a build that has debugging disabled, these kinds of things will just disappear. So I'm not too concerned. Yeah, see, like most of the time is spent now just calling this callback. And you know, there is one thing I could do probably to improve this. I don't know if the cost... Do call and its children contain 93 samples. Yeah, it's because what this ends up calling, I guess he doesn't want to show it to us here, unfortunately. But what it's actually bound to yeah, no, I know. So yeah, so these are the callbacks here, the on-read callback and the on-write callback. And if I go to my debugger, so these are the callbacks. So every time we do any read or any write, we go through this code that checks if trace is enabled. I want to add a memory access, which is trace is enabled, by the way. And I also check if, I also look for whether the address is in my breakpoints. So all of this code is happening for every single read and write. So definitely it's not cheap, you know. Yes, right now, definitely removing this would make a big difference, there's no doubt. I was thinking about that, like having a non-debugger build, but it's been just, you know, for me while I'm developing, it's much more useful to have the ability to set these kind of breakpoints and stuff. So it's like part of the overhead. Like if I just remove these, you'll see it makes a huge difference. Oh, you mean these ifs here? So yeah, this is because, so the callback enabled is kind of like for when I write trace info, I have to make sure that callbacks are disabled because of, what is this again? Oh yeah, because I don't want to hit, hold on a second. Because when I'm doing the trace, like the trace information for the debugger, I don't want that to cause breakpoints to be hit. I think that's what it was. Yeah, because see, I'm doing a read instruction, and then that ends up reading again, like on the memory bus, and I don't want those reads to go and affect the tracing and or breakpoints. Because I don't want to reset it back. Oh, you're saying it could shadow the function pointer? Yeah, yeah, for sure. It's not going to make a huge difference. It's not that the cost. I don't think it's the condition check, you know? It's really the callback. It's just doing so much. Now, even so, we're not really getting much. Yeah, I know. But yeah, you have to be judicious with these kinds of things, right? Did I mention performance optimization is hard? Yeah, so now see the cost just keeps shifting around. Yeah, no, I could do the pipelining for sure. There's so much that could be done. But you know, the truth is, so the only reason I'm even looking at this is because I find it really slow when I'm doing the syncing, and I was wondering if like I could improve the performance. But all of this is just for debugging. When I run the emulator on its own, it's not that slow on my crappy computer. You know what I mean? But yes, exactly. Lift one stone. I like that. Lift one stone and then everything hides under another. Exactly. So I just keep like fixing one thing and then another one shows up. But unfortunately, it's not giving me the kind of gains I would have expected. And now at the point where really the extra cost, at least outside of the rendering, has mostly to do with the fact that I have a debugger, right? So if I went ahead and did what I was saying earlier, which is have a non-debugger build, like let's say the release build for just running the emulator, playing games. A lot of this would just disappear. I would just be, executing instructions. And in fact, I was thinking a lot about how I would do exactly that. Because the way it works is right now the debugger kind of drives the emulation. See here in main, in my update here, like if we just ignore the sync protocol stuff, this here, like the main part is right here, debugger.update. Oh, it's clocked at 1.5 megahertz, is it? 1.5, no, sorry, what? Yeah, 1.5 megahertz. Yeah, exactly. It's got basically a 6 megahertz timer, but then it gets, divided by 4 for the CPU frequency. So what I was saying is that the debugger drives the emulation, but it basically boils down to this one function that's called execute instruction. So this is what gets called, right? For the number of instructions I need to execute, and then in there, let's see here. So execute instruction. So like the main loop is here. What I have is I have a delta, like a slice of time, and I say execute as many instructions that can fit into this time slice, plus one more at most. So yeah, exactly. And so basically I keep track of how many CPU cycles I have left, and I add how many CPU cycles for this frame. So this allows me to keep the leftover, the error, which spreads out over multiple frames. And then here I call execute instruction in this loop while I still have CPU cycles left. And if you look at this, so much of this is just debugger code. Like here, breakpoints, checking if I have to break into the debugger, more break into debugger stuff. So really the core is just this like loop of calling execute instruction. And then within execute instruction, again, there's more debugger only stuff, And all that really matters in here is these lines right here. For each instruction, I execute the CPU instruction, get how many cycles just elapsed from it, and then I update my VIA, which is the other chip that I emulate, which is the one that drives the rendering and the joystick input and eventually audio. And that's it. That's really the core of the emulator. So if I just extracted these, these little bits, yes, the exceptions are expensive as well. Those two I would remove. All this try-catch stuff, it's only really there for the debugger. So for that, what I've done is I have I have some throws here for like when asserts occur, right? But I want, what I didn't do yet, but what I want is for these asserts to, when I have, let's say, a release build, a non-debugger build, these will no longer be throws, right? They'll just be like a proper assert, and it'll just assert there and it'll be done. So the assertions will, the exceptions will disappear once I don't have a debugger and be replaced with proper asserts. So the try catches, which are only really in the debugger, won't be there. Yeah, all of it will make a big difference. Although exception costs in modern compilers, they're not the same as before, right? It's not like in the old days where having try catch immediately slows down everything. It is more on the unwind, yes. But they've made lots of improvements, and from what I've understood, even on latest consoles like Xbox One, where you pretty much have to use it, they optimize it so that it's no longer the big cost that it used to be. But there is still a cost, for sure. Like you say, it has to be prepared for the unwind, right? So there's some optimizations that can't occur because of that. So anyway, all that to say is that when I make like a version that is non-debugger, so non-development, like I make a non-development build or a real release build, all of this would disappear. No more try catch, no more throwing, and none of all of this, right? And I would just have a very nice and efficient execution of the CPU and updating of the VIA. So there's that. I would also get rid, obviously, of the sync protocol stuff. All that would disappear. All these would be, you know, put behind a macro or something. So maybe I'll work on that at some point. I kind of do. Yeah. But you know what? That's not actually where most of my cost is, so. Yeah, I don't know if it was fun. I don't feel like I got anywhere tonight. But it's alright. Looking at traces and trying to understand how things are going. It's always information, right? Alright, take care, Lisp Gamer. I would like to try to fix this thing with the lines. See if I can make it work. I'm gonna try something. Start with a static. So I'll say I don't know what to call it, but let's just say previous drawing enabled. So what I'll say is now, if drawing enabled, if it was previously enabled, and that's not all. I guess I need to know about the direction we're moving in. Yeah, I need to know about the direction. So it's this delta here. Actually, I can just use the velocity. I don't need the delta here. So I can use... Okay, let's write a normalize function. I need to also have a magnitude function, I suppose. Do I need to go in this direction? I suppose I do. Okay. Do I have a division? I do. Okay, so normalize would be returning v divided by v's magnitude, right? Or by the magnitude of v. And now I need a way to compare Okay, so let's see if I got this right. I think I got this right. Let's make it inclusive for the epsilon. Alright, so if this was previously enabled, if the velocities, so if we normalize the velocity, is if the normal of the velocity, what did I call it? Did I call it normalize? I did. Hey, how's it going, Synchron? So if that is to the previous draw direction, okay, so then we do like coalesce here. I don't even know how to spell that. Like that. Okay, so what is it doesn't like here? Normalize. Const vector. Initial value of reference to non-const. Oh yeah, okay, it's for the almost equals. So we're looking to see if the velocity changes direction. Now, if we were still drawing, so if we didn't like raise our pen, you know, our beam, so we were drawing previously, we're drawing again, and the direction hasn't changed, then what we can do is we should be able to take the previous line, assuming the previous line, let me think here. Yeah, because if the beam is moving in a direction and it's not drawing, and then it suddenly starts to draw, we're not detecting that. Oh no, I guess we are, because previous drawing enabled would be false. Okay, so let's just try to see what would happen. So in that case, we would just grab the value off the back and set its second, you know, P1 to M position. We just we overwrite with the current position. Otherwise, we need to insert a new one like this. So let's see if this actually works. This relies on a lot of stuff, so probably got some stuff wrong here. So Synchron, is this your first time here? Okay, well it looks like so far it's working. Oh, I was wondering what you meant by that. I think it might be. I have a familiar face. So yeah, this doesn't seem to have made any difference. So tonight I've spent most of the night making no optimizations. Trying to optimize stuff and not really getting anywhere. It's kind of funny. But it's interesting to see that's actually working. Like it seems to be working without, you know, like on the first try, which is kind of cool. I'm gonna have to do more profiling to see, but it's cool. It seems to work. You know what I would like to do? No, it's okay. Lots of food for thought here. I don't know. Okay, well, this optimization we could definitely keep. Yeah, this one's interesting too. It doesn't make the code any less readable, and it is a good optimization. This one I'm not so sure about, the coalescing. This one actually does make the code less easy to understand and doesn't seem to be giving us very much. Okay, so this one I'll grab this one here. And as for the other ones, so technically it would be more like this. We'd remove this. Fail message, okay. Oh man, I totally know that feeling. When I watch other people programming, I do the same thing. You want to see what you want to see my code, and you start scrolling. It doesn't work. If there's anything you want me to explain, just ask. I can show you. I don't mind. I mean, all of this is available on GitHub as well, right? Like, not the version that I'm presently editing, but if you wanted to look at the code, I push often, so, you know, version that is, I just now committed, but the last one that's on GitHub was pushed just a couple days ago. Right, just looking at it, just a reflex, yeah. But if you do have any questions or you want me to explain something, just, you know, you can ask. I have no problem with that. I enjoy sharing how I did things or talking about it. All right, so let's say we keep this one as well. So I'll say here, replace linear lookup in memory bus by, I'll say kind of like for device by address in memory bus with O1 lookup. And on this last one here, with the coalescing lines, I'm just going to stick that on a branch and maybe revisit it later. When I'm not sure, I do this, you know. This is the beauty of Git with its easy branching, right? Just stick it on a branch and take it later. Alright, well, didn't get as much done as I thought I would, but we did explore a little bit of the performance profiles of the emulator. Attempted some optimizations. Nothing major gained. I need to spend a lot more time really digging down. I think I really need to understand where I think the biggest hit right now is in the rendering. So I'd have to like drill down more into that and see where we're spending time and optimize that code at some point. But I mean, I'm not too concerned. I think it's running fairly well. Again, my machine is not a very good one. Right now my CPU is heavily being used and taxed by OBS. Running right now at 44%. But see, when I have the focus here, we're getting about 140 FPS, so that's perfectly fine. And again, you know, once I get rid of all these things that I don't need, the debugger, the even this thing here, the ImGUI stuff, all of that can go in the final version, and this will definitely give a huge speed boost. Enable graphics card encoding. Yeah, so yeah, absolutely. I just don't have a graphics card that supports it. I know, if I did, OBS would not show up on my CPU profile here, but it's I've got a crappy video card. And I wanted to buy one. I mentioned this last stream. I wanted to buy just a regular graphics card that could support that. And thanks to Bitcoin mining, even like a couple, even a graphics card from like a couple years ago is still relatively expensive if I get it, relatively new. And you got to be careful, right, buying secondhand cards, because if people use them specifically for Bitcoin mining, you just don't know like how much life is left on them. So it's a bit I don't know where, I need to kind of trust my source when I buy one. So yeah, I definitely need a new graphics card. It would be very helpful for the streaming. So we'll see. I'm on the lookout. Bitcoin dropped like an anvil. Well, has it started to affect graphics card prices yet? Yeah, GPUs will drop eventually. When it does, I'll be happy. I'll take a look at what I can get. And I don't need something super awesome. I just need a decent graphics card that can do the encoding. But you know what, guys? I think I'm gonna stop it here. So Synachron, thanks for joining. If it is indeed your first time, if not, thanks for coming back. Yeah, and I'll be back next Monday, and we'll keep hammering at this emulator. So yeah, thanks guys, and I'll see you next time.